Now let's look at the last topic under matrices, which is the determinant of a matrix. We can only find determinants of square matrices. If the matrix is not square, the determinant will not exist. Same thing for inverses. You can only find the inverse of a square matrix. If the matrix is not square, the inverse will not exist. Let's look at the notation for a determinant. N by N matrix has to be square. It can be written as DETA, or these two straight lines around it indicates that you're finding the determinant. I prefer either writing it out, find the determinant of A, or DETA. These two lines can be confused with the lines with our brackets that go around our matrix. So let's do 2 by 2 matrices by hand, 2 by 2 determinants by hand, just like we did 2 by 2 inverses by hand. So for your generic 2 by 2 inverse, A, B, C, D, look at the formula for the determinant. The determinant of A is defined as AD minus BC. We saw that earlier when we were doing inverses. Where did that AD minus BC come from? Well, let's see if we can back up and find it. One more. There we go. When we were finding the inverse of a 2 by 2 matrix, the AD minus BC appeared here in the denominator. So we were actually calculating the inverse, or we're actually calculating the determinant to find the inverse. It was used in finding the inverse. Anyway, let's get back to determinants. There we go. So it's just the cross product AD minus BC for any 2 by 2 matrix. So let's look at our first matrix. 2 by 2, 7, negative 8, 5, 2. We're going to calculate the cross product AD minus BC. AD 7 times 2, which will be 14, minus BC, negative 8 times 5, which is negative 40. Well, watch your signs. This will be 14 plus 40, which is 54. That's our final answer. That's the determinant. The determinant is a single number, can be positive, negative, or 0. Let's calculate the cross products here and subtract them. AD minus BC. AD will be 4 times negative x, negative 4x, minus BC, 15 times y. So just negative 4x, minus 15y. So in this case, it's an expression because of the x and y. Finally, AD minus BC, 9 times 2, which is 18, minus 6 times 3, which is 18. So here the determinant is 0. 3 determinants, positive 1, a 0, 1, and 1. That's an expression. Now let's expand on this guy a little bit. If my determinant is 0, it actually determines something about that matrix, which is an important thing that I don't have written on here that you need to write down. But if the determinant of A is equal to 0, then A inverse does not exist. So the determinant does determine something. It determines whether your matrix has an inverse or not. So if the determinant is 0, your matrix does not have an inverse. Just an interesting point. If your matrix is larger than a 2 by 2, we're going to go to the calculator, put it in, and find a determinant find a determinant using that technology. So here's 2 matrices, a 3 by 3 and a 4 by 4. Let's pull out the calculator and type those in. Okay, so if you type matrix A into your calculator, I've already typed it in. There's my matrix A. To find the determinant, we're going to use a feature that we hadn't used before under matrices. Press second matrix, We've used the names in the edit feature, but we've not used the math feature. Notice the first option under math, DET. So that's where we'll go to find the feature that will find the determinant of a matrix, if that makes sense. So, second matrix, middle part, math, hit DET, and what you see is DET comes up on your display, and now all you have to do is tell the calculator what matrix you want it to take the determinant of. So I put it in matrix A. So I'm going to pull under names, matrix A, and tell it take the determinant of matrix A. It'll just spit back your value. Remember, it could be positive, negative, or 0. Here, the determinant of that matrix is negative 44. Do the same thing for matrix B. It's a 4 by 4 matrix. So put that in anywhere you want. It doesn't matter what name you put it under, just so you put that one in your calculator. So go to your calculator, type in this 4 by 4 matrix. I actually put it in under my matrix B position, 4 by 4. So I want to find the determinant, pulling up the DET feature. I want to find the determinant of matrix B because that's where I placed my matrix. You don't need to close that parenthesis, that parenthesis off. But the determinant of B, you should get 68. So type in that 4 by 4, find the determinant, and you should get 68. So that's it for the matrix information.